This video is about protein digestion. There's videos about carbohydrates, nucleic acids, lipids. This is protein. And for protein digestion, all the same physical things happen as with any other type of macromolecule, except for lipids. Remember, they had emulsification, which was extra. But for lipids, you put them in, or sorry, proteins, you put them in your mouth, you chew them. That name is mastication. We could also just say chewing. Everybody knows what we mean. We swallow them. They go down the esophagus, not the trachea, because the epiglottis blocks that off every time we swallow. They go down the esophagus by the process of peristalsis. Peristalsis is the squeezing of muscles that lets us swallow even when we're lying down or doing a handstand, although some of us never do handstands. But if we did, we could still swallow. If we traveled to space, we could also still swallow, which again, most of us never do. The protein will go past the esophageal sphincter and still nothing chemical has happened. Nothing has happened to attack the bonds in between the amino acid monomers. But when we get into the stomach, this is where we have our first bit of chemical digestion with the enzyme pepsin, which is from a precursor called pepsinogen. Pepsinogen is a precursor enzyme. It's not a functional enzyme yet. It gets activated as soon as there's acid in your stomach. There's not acid in your stomach full time because that would hurt your stomach tissue. Same reason there's not pepsin in your stomach full time because your stomach is made of mostly protein. We wouldn't want to be digesting it all the time. So instead we make this thing that's almost ready to be pepsin, and as soon as our stomach starts to stretch, then it turns into pepsin. So pepsinogen turns into pepsin as soon as there is the right pH, and that pH change comes from hydrochloric acid. So this has to be at a very low pH, an acidic pH. In the stomach, there's churning and peristalsis. Those are physical processes that mix things around and break them apart. Peristalsis is just at the end. We empty the stomach through the pyloric sphincter, just like always. The pyloric sphincter opens up once the pH in the stomach becomes too low, because your stomach keeps on adding a little bit of acid, but eventually that acid stops having anything to react with or mix with. And if we keep adding it at that point, we're just digesting our own stomach. So when the pH drops too low, the pyloric sphincter will open up and peristalsis will squeeze all of that chyme through into the duodenum, the first part of our small intestine. The duodenum, jejunum, and ileum are all part of your small intestine. The duodenum is where your pancreas and your gallbladder both enter. So the common duct for your pancreas and your gallbladder is sometimes called the common duct, or sometimes called the pancreatic duct, or sometimes called the bile duct. But your liver makes bile, gallbladder stores the bile, pancreas makes all kind of digestive enzymes plus bicarbonate ions to neutralize that stomach acid. All of that goes into the duodenum, and a lot of those enzymes that are made by your pancreas, some of these are truly made by the walls of your duodenum, but we'll just call it pancreas for now. Trypsin, chymotrypsin, erepsin, peptidases, and proteases, they all work to break those super long chains of amino acid called proteins into smaller chains, called polypeptides, and then into even smaller polypeptides, and then finally into individual amino acids. So one amino acid at a time. That's our goal. That's our product. That's what we want. We can use that to build new proteins. Remember the bond between these, when they are joined together, that bond was called a peptide bond. Which makes sense here for the peptidases, because peptidases break apart peptide bonds. And pepsin breaks apart peptide bonds. You'll also notice something interesting about the enzyme names for proteins. Lots of them end in A's for everything else, and there's some A's here. But there are also a bunch of them for proteins only that end in in. And that's because we found these ones earlier before we decided about the naming convention about enzymes. They're just an older name, so they're following an older thing. Ending in IN means I'm a protein. All enzymes are proteins. And these ones were named as proteins before we had a special subcategory of proteins discovered called enzymes. So lots of enzymes to remember about proteins, more than any other macromolecule. In the duodenum and the jejunum, you have peristalsis and segmentation, just like for everything else. You have peristalsis in the large intestine, but again, that's not relevant because the good stuff will already have been absorbed. In your last two sections of your small intestine, the jejunum and the ileum, the end products of digestion of proteins, amino acids, get absorbed through the villi. They get absorbed by active transport, just like everything else that goes into your blood. The only thing that has any aspect of passive transport were those triglycerides that come across that cell membrane a little bit easier. So remember, amino acids are joined together by peptide bonds. If you have two of them together, that's called a dipeptide. If you have more and more and more and more joined on, then you get a polypeptide. And if that polypeptide is folded in the right shape and has a job, it's called a protein. So for proteins, the biggest thing to remember, apart from what they're made of, amino acids, is that they have way more enzymes to remember in Bio 20 than any other macromolecule.